In this video, we're going to be exploring how we can perform a topology optimization using ANSYS. So on the screen, you'll see that I've got a basic component. So this is designed to be a bracket, and its height's 200, its length's 200, and its depth's 20 millimeters. Okay, and if we have a look, I've ported my model, I've meshed it, I've got a pressure on the top of 25 megapascals, and I've fixed this back face. Okay, so there's no movement in any of the degrees of freedom. So when I solve this, obviously I can find out the deflection of the component. I can have a look at the stress distribution in the component, and we can also have a look at the safety factor. Traditionally, what we would normally do is take this information now and we could modify the bracket so that we remove mass where it's not needed, okay, and then we'd have to rerun the analysis, check that it's still compliant. Now, with topology optimization, it will give us a basic shape that meets our specification by basically rerunning the analysis over and over. So in order to do this, we need to go back into Workbench. You can see that I've got my static structural system here. And what I'm going to do is go topology optimization, click, and I'm going to drag this onto the solution here. So all of this data from the original analysis will be drawn in, and we can go and set up our model. So if we go back into mechanical, you'll see that I've got this new portion here. So it says topology optimization. And we can change some of the parameters. So we've got the optimization region. So I want the region that I would like to remove material from. So that's highlighted in blue. And where I have boundary conditions, these have been excluded. Okay. So for a bracket, that's okay. The back face is going to be bolted onto something, and that's where our force is going to be applied. Now the objective, okay, so this is where we're telling it. So it says response type. So we've got compliance here. So that just means that minimal amount of deflection. And in response constraint, if we click on this, you'll see in the details section down here, we can change the amount of mass that we'd like to keep. So in this example, I would like to retain just 30% of the original mass. And that's pretty much it. So it will take the data from before and it will rerun the analysis until it comes up with a solution that gives us the best compliance for the amount of mass that's available. So all I need to do now is right click solution and click solve. Now the thing to remember here is that these solutions can take a lot of time. By clicking on the solution information and then density tracker, this will show us the current state of the process. Okay, so once it's complete, it will give us some geometry. And a few things to notice about this. Okay, it would be very difficult for us to manufacture this using conventional techniques. We could 3D print it, no problem, but we'd still need to do some post-processing to this design. So topology optimization is a great way of getting us close to our final design.